Hi everyone, welcome back to CodeY, and today we'll be doing a question called longest substring without repeating characters. So it's quite a mouthful, but this itself is sufficient to explain the question. We need to find a substring in a long string such that there's no repeating characters inside the substring. So for instance, ABC is the longest substring, BCA is the longest substring, CAB is the longest substring, ABC once again is the longest substring because any further like ABC expanded by just one more index would have a repetition inside it itself. So here's C, here it is B, and here it is A. So how do we do this? So in a brute force method, we can just say we see every combination of it and see if it already exists inside, but that sort of defeats efficiency. Like it will be seeing everything again and again, like it'll be n to the power of 2, that kind of thing, or something ridiculous. So the idea that I want to work towards is a logic where I'll just see everything just once. So for that to happen, mainly it comes with a bit of planning, and we can work it out. So mainly what I'll be doing is I'll be using this tool called a two pointer, keeping track of 2 pointers like starting point and ending point. And I will also make use of a hash map. So there's a common meme in these type of Leetcode questions: when in doubt, throw a hash map. So how is it going to work? So what I'm going to do is I'm going to traverse this once, and when I'm traversing, I'll be keeping track of the starting point that I like and the ending point I like. I'll keep track of the index inside the hash map. So I'll look through this A, uh, and I'll put it inside the hash map. So A will be equal to 0, B will be equal to 1, C will be equal to 2, and as I'm going to the next one, uh starting point is still 0, and my ending point is whichever index that I'm at right now. My ending point, when I go to the next element, which is A is already seen inside. I'm able to traverse to the next because I haven't seen it in my hash map so far. A is not seen at A, B is not seen at B, C is not seen at C. A is seen, so I'll go to A and I will change it to the new A that I'm seeing over here, which is index 3. And I will set up the starting point to not be 0, but to start from one step in front of A, like the previously seen A. That way, BCA can exist, starting point to be 1, and ending point to be the index that I'm currently standing at. Then I continue again. I go to B. The next element is B. Is B inside hash map? Yes. And I will look at it. I will change the starting point from to one step in front of the B element. So these things, I'll change this to 2, and it'll be from 2 all the way to this part, and it still works. CAB works. And uh subsequently I'll just keep going. I would have to change this to the latest 0, 1, 2, 3, 4 index, and so on and so forth. And that is the logic behind it. I'll just, I'll look at the next element. If it's inside, I will update the index and I'll update the starting point one step in front of the previously seen element. So with that, let's try coding it out. I'll leave the drawings on the side as well. I'll just start coding. So what I want to have is I'll have a character dictionary that keeps track of the indexes to keep track of indexes. Maybe I should just do this. Keep track of indexes. And I will also need to have a pointer, which is a starting point, which will be currently 0, and a maximum length, which is also 0 because there could be a case where there's no string inside and we may need to return max length. At the end of the day, we want to return this as the final answer. So next up, I'm going to do a for loop. And for this, I'm going to use enumerate. So save some space coding it out. So for index and character and enumerate, if character is inside the character dictionary, I do something. And if it is not, I do something. So if it is not, I think that's the easier part. If it's not, we just add it into we just add it inside, like we just add the new element into the hash map. So which is character dictionary, character is equal to index. Now, if it is inside, what do we need to do? First thing that we need to do is we need to change the starting point. So the starting point needs to be, the starting point is a little tricky. The reason is because we cannot just blindly shift the starting point in front of this thing. We cannot just blindly shift it in front of the previously seen alphabet. Like for instance, A, B, C, and we have A. In this case, A is over here. We go to the previously seen A and then we cut it and push it in front. And we say the starting point is now 1. And the ending point is ending index is 3. So the difference between 3 and 1 plus so the difference between this is the longest substring, whatever. Like we are able to do this in this case, but let me present a counter example, which is A, B, B, A. In this case, A doesn't exist so far. I add it to, okay, let me clear all the drawings as well. So the new substring that I want and that I'm interested in, A, B, B, A. Now, it's important that we keep track of the different combinations of things as well. So what's going to happen now is, let's say A. We haven't seen this in the hash map. We add it into the hash map. Nice. A is 0. B, we haven't seen it. We add it into the hash map. 1. Starting point is 0 so far, and ending point is 0, 1. Like ending point will just be the index that we are looking at right now. Next up, we go to B. B is inside already. So starting point will go to the previously seen B, which is 1 and plus 1. So starting point will then get converted to 2. And the ending point is also 2 because that's the index that we are on. So the max length of the item is currently stands at AB. And that's the answer that we should have returned. I mean, that's the answer that makes sense. Okay, but what's going to happen is the issue comes when you go to the next element, which is A. Now, A, the previously seen element for A is 0. And if we say, I will go to A and then just put one step in front, it ignores the fact that we already went beyond this starting point. Like we already ensured that our starting point is at minimum here. Like our starting point must be here. Our starting point cannot go back to some place before this. So I think that's the best way to put it. Like we cannot go back to a different starting point. Like we cannot reduce the starting point's number. We have to keep the starting point here or above. So to do that kind of logic, we are going to implement a maximum. Because what's going to happen is if we don't do that, our A will be, our new starting point will actually reduce to 1. And our current ending point is 0, 1, 2, 3. So 3 minus 1 plus, so it'll count the new longer subsequence to be this, and it's just 3. 3 is larger than 2, and it'll return this as the final answer, which is wrong. So to avoid this situation, what we can do is we set a floor kind of value, like a maximum value. Like we're ensuring that it's either starting point or it is larger than the starting point. So to do so, like we must make sure that basically we don't go below the starting point. So we'll put the starting point as starting point there, and we will put what was the logic previously. We will find the previous character and add one step to it, right? So we will do that as well. Character dictionary and character, whoops, +1. Like we go to where the character was seen previously and +1 to make it the new starting point. That idea is still there. and it's only if it is larger than the starting point. It cannot be smaller than the starting point. We shift the thing backwards. That thing is not going to work. So after we change the where's the starting point, we need to modify the character dictionary to have this. Since we are doing this regardless if it's inside or else it's inside, we can just remove the if else and move it here. And after that, what we need to do is we need to find the maximum length. The max length is going to be max of itself and uh, current index minus starting index plus one. The reason for plus one is because, like for instance, when it's 0 and 0, it'll just be 0 minus 0. It'll just give us nothing. We need to have plus one to account for the distance, which is 1. So starting minus index minus start and plus 1, that will give us max length. And we can just return this. Return max length. And that should be the answer. So let's run this. I'll clear my annotations. Whoops, I made some mistakes. Okay, right. I shouldn't have this. Let's run this. Spelling mistakes. Character. It's quite embarrassing. Okay, so expected is 3. Basically, by doing this, we're keeping track of itself and whatever is the new starting point, the ending point minus starting point as the new distance. So this logic will just traverse through the whole string once because we only have one for loop and we're not doing any like loop to loop kind of thing. We are, okay, let's just make sure that it clears all the test cases as well. So yeah, wonderful. It beats 98% of the users using Python, and it's also quite memory efficient. Pretty good. But let's analyze this to just break it down a little bit further. This is O(n) time complexity because we are for looping through the whole sequence. We're seeing everything at least once. And I think that is as good as we can expect. It's decent. And we are also creating O(n) space complexity because we're creating a new hash map. And in the worst case possible, each and every single element would be inside the character dictionary. And that would mean N and N. Not bad. And I don't think we can do anything better than this. But always keen to learn more. So if you guys have any suggestions and any ways to improve this, always all ears to improve. So yeah, I'll see you guys in the next video and hope you guys enjoyed this. Thank you.